All right, we're back. We're just going to work on another example of what we covered in the first video. So now we have matrix M, and we want to know what are the dimensions of matrix M. So we're looking at 3 rows and 4 columns. So the dimensions very simply are going to be a 3 by 4 matrix. It says, what's the entry at element M32? So if I give you the address M32, it's not really 32, it's a 3 and a 2. We're looking at the third row, second column would be the number 11. So M32 would be the number 11. And it says entry 0 appears at what 2 different addresses? Since we are looking at capital M as the matrix, we will use a lowercase m. And 0 is going to show up on the second row, third column. So M23, that's a lowercase m, but it's also going to be in the first row, fourth column. So we would go M14 for that first row and fourth column. Once again, rows are horizontal, kind of like an X value. Columns are vertical. They go up and down, kind of like a Y value. So X always comes first and Y goes second. That's how you determine your rows and your columns for your dimensions. 3 rows, 4 columns. Excuse me. All right, let's go ahead and move on. For the next one, what we're going to do is add and subtract matrices. And so in order to add or subtract them, the dimensions have to be the same. Here we have a 2 by 2 matrix plus another 2 by 2 matrix, which is perfectly acceptable. This one here is going to be a 3 by 1 matrix, 3 rows, 1 column, plus a 3 by 1 matrix, 3 rows, 1 column. And that is perfectly acceptable. However, if the dimensions don't match, this is not possible. We could also use the words does not exist. Some people would say null set. Those are all ways to say that you can't add those together. So if we're going to add them together, and once we have the dimensions that are the same, it's a really simple process. Here we have a bunch of matrices. And so if I'm doing matrix A plus matrix C, first I want to check and see that the dimensions are the same. Matrix A is a 3 by 2 matrix. It has 3 rows and 2 columns. Matrix C has 3 rows and 2 columns. So you are allowed to add them together. We'll just take this first number in the first corner and add it to the first number in the first corner of the other matrix. So A plus C is going to be a 7. That'll be the first corner. And then negative 2 plus 2 is going to be a 0. Use your integer rules correctly. Negative 3 plus 0 is a negative 3. 10 plus negative 9 is the same as 10 minus 9, which is 1. 2 plus negative 5, same as 2 minus 5. This will be a negative 3. And 6 minus 14 is going to give me a negative 8. And that is the answer. We just create a new matrix. Since it started off with a 3 by 2 matrix, I know that our answer is going to be a 3 by 2 matrix. We're not really going to assign a letter to it, but that's how that would play out. If I'm doing C minus A, I would start off with matrix C and subtract matrix A this time. Once again, we know that the dimensions are the same, so all we're going to do is take the number 3 and subtract the number 4 from it. All right. And this would give us 3 minus 4 is a negative 1. 2 minus negative 2. If you need to write it down, I highly suggest that you do just to get it in place. Whenever you subtract a negative, you're really adding a positive. So 2 minus negative 2 is going to be the same as 2 plus 2, which is the number 4. Excuse me. Next, we're going to do 0 minus negative 3. And once again, if I do 0 minus negative 3, I'm really doing 0 plus 3, which is going to be 3. Let's try negative 9 minus 10 is going to give us a larger negative number, negative 19. Negative 5 minus 2 is going to be negative 7. And 14 minus 6 is going to be an 8. Booyah, ta-da. On the last one, they want us to do matrix C plus matrix B. If we take a look at matrix C, the dimensions are a 3 by 2. And if we take a look at matrix B, it is a 2 by 3. Even though commutative property 3 by 2 and 2 by 3 are the same, unfortunately, these dimensions are not the same. And so the answer to this one would be not possible, Mr. Studer. Oh, this guy right here. Oh, yeah. All right. So with that in mind, let's go ahead and work on one more example for that one. Then we'll move on. We have one more example after this to do, but this won't take long. Let's go ahead and do B plus D. We're going to take matrix B and add matrix D to it. B is clearly a 2 by 3 matrix. D is a 2 by 3 matrix, so it's perfectly legal to add those together. 4 plus 0 gives us 4. -1 plus 1 is going to be a 0. -5 minus 3 is going to be a -8. If I do 3 plus 3, it gives me 6. 2 plus 0 is a 2, and 8 plus 10 is going to be an 18. And all I did was add together those same positions, 8 plus 10, and I put it in the same position so that 8 plus 10 is an 18. There we go. Now we'll do B minus A. Matrix B is a 2 by 3, and A is a 3 by 2. Those matrices do not match up, so this is going to be not possible, which would be an answer you would select on your quiz. The next one is going to be D minus B. So if I'm looking at matrix D, I have a 2 by 3, and B is a 2 by 3. So you can do D minus B. 0 minus 4 is a -4. 1 minus -1, if you need to write it down, 1 minus -1 is the same as 1 plus 1, because whenever you subtract a negative, you're really adding a positive. The answer of 2. If I have a -3 minus -5, that'll also be a 2. 3 minus 3 is 0. 0 minus 2 is a -2. And 10 minus 8 is a +2. We got a lot of 2's in that particular one. All right. So that's how that works. We added and subtracted matrices. I'm going to see you in the next video. We're going to cover a scalar. It's a really simple thing. We're going to multiply just one number to a matrix. We're not actually multiplying matrices together. That'll come tomorrow on the next videos. But for now, we're going to go ahead and stop this one, and we'll do a scalar next. One more video coming. Go team.